All right, diving in today, folks, we're going deep on how computers are starting to, well, really understand sound. Not just like, oh, that's a doorbell, but more like grasping the whole story a sound tells.
It's pretty amazing.
Yeah, we're talking audio question answering, or AQA for those in the know, but with a twist. The research we're looking at today is using something called reinforcement learning, and it's kind of shaking things up.
Definitely shaking things up.
So our mission, figure out why this is a big deal, what it means for the future of AI that can, actually listen and get it.
Right. And the research you send over, reinforcement learning outperforms supervised fine-tuning. A case study on audio question answering from Xiaomi Corporation. That's a great place to start. They're pushing these large audio language models, the LALMs, past just like transcribing or labeling. We're talking actual comprehension, reasoning based on what they hear.
Okay, so AQA, audio question answering, sounds simple enough, but the researchers are saying it's way harder than, say, just knowing a cat's meowing. What makes it so tricky?
Well, it's the level of processing involved, right? Think about it. Automated speech recognition, turning spoken words into text, or even audio captioning, describing the sounds, those are building blocks, yeah. But AQA, that takes it a step further.
Okay.
It's not just about identifying a sound, it's about pulling out meaning from raw audio, understanding how different sounds relate to each other, and then giving an answer that makes sense in the context of what's being asked. Like, not just, there's a siren, but why is that siren blaring based on everything else I'm hearing?
So knowing the ingredients versus understanding the recipe and how they all work together.
Exactly.
Now, the report says AQA is a prime way to test if AI can really, truly reason using sound. Why is that?
Because it combines both sound and language understanding, right?
Yeah.
It forces the model to integrate those two things in a way that other audio tasks don't. AQA can involve a single audio source, or it could involve multiple audio streams that need to be like untangled and synthesized. And the answers can be different too. Sometimes it's multiple choice, other times it's open-ended.
Right, right.
This particular research, they focused on single audio tasks with multiple choice answers, which brings up this generation verification gap.
Generation verification gap. Okay, break that down for us.
Basically, think of it this way. For an AI, generating the correct answer from just the audio, that can be super hard. But verifying if a given answer is right, once you have some options, that's a lot easier. And this kind of setup, that's where reinforcement learning often shines.
Makes sense. So how did the researchers use reinforcement learning here? What was their approach?
They used an algorithm called Group Relative Policy Optimization, or GRPO, and they applied it to a LALM called Qwen2 Audio 7B Instruct. Now, this model, it's no slouch. It's got 8.2 billion parameters. That means it's already been trained on a ton of data.
Okay, so it's got some experience.
Right. And they wanted to see if this RL method could beat the more traditional way, supervised fine-tuning, or SFT, which has been the gold standard for refining these models.
So what does the reinforcement learning process actually look like? What's the AI getting rewarded for?
Well, imagine training a dog with treats. The RL model, it learns through trial and error, but it's guided by this reward system. In this case, the model got a +1 reward for picking the right answer to the audio question. But there's a twist. Depending on the prompt, it could get another +1 if its reasoning was inside these special tags, think, and the final answer was within answer. Wrong answer or wrong format, no treat, 0 reward. So they're encouraging the model not just to get the answer right, but to maybe potentially show some kind of thought process.
They experimented with different prompts for the reinforcement learning, right? Like one asked for just the answer, another asked it to show its work first. What about the supervised fine-tuning? What kind of prompt was used there?
Yeah, for SFT, they kept it simple. Just give me the answer. No need to explain itself. And that's a crucial difference when we look at what they found.
All right, so spill the beans. What were the big surprises? What really jumped out at the researchers?
So one huge thing was that RL didn't just do a little better, it blew SFT out of the water. And get this, it did it with way less data. Like they only used around 38,000 examples from the AVQA dataset for RL, and bam, state-of-the-art performance on the MMAU test mini, which is a pretty tough benchmark. 64.5% accuracy, that's huge.
So less data, better results. That's really turning the tables on this idea that you need mountains of data for good AI.
Absolutely, it's all about efficiency.
What else did they find?
Another big takeaway, that GRPO algorithm, it worked really well on LAMs, even a relatively smaller one like this one at 8.2 billion parameters. So that means RL isn't just for the super advanced top-tier models, it could be used more widely.
Okay, so RL is looking pretty good. But the report also talks about this enigma of deep thinking. What happened when they tried to make the model show its work?
This is where it gets weird. They thought that explicitly asking the model to show its reasoning using those think tags would make it better, kind of like how chain of thought prompting has helped in other
Yeah,
areas.
it makes sense.
But surprise? It didn't really improve accuracy on the AQA tasks. Asking for the thought process didn't change much compared to just asking for the answer.
So all that effort to get it to explain itself, no dice.
Nope. And what's even more interesting, when they looked at other attempts to use chain of thought with audio, those are pretty limited too.
Huh. So maybe the way these models handle sound is just fundamentally different.
That's what it looks like. Like our usual tricks for getting AI to show its work, they might not translate well to the audio world. Definitely needs more research.
For sure. And even with all this, the researchers say there's still a big gap between AI and humans in audio understanding.
Oh, absolutely. Even with these great results, the models are still behind us when it comes to truly understanding and making inferences from what we hear. It's a reminder that RL is a powerful tool, but we're still in the early stages of figuring out how to bridge that gap.
Okay, let's talk about how they set up these experiments. Where'd they get the data?
They mainly use the AVQA dataset, which is actually
Mhm.
for audio-visual question answering. So videos with sound and visuals, plus questions and answers. They focused on the audio and text parts, basically changing video to audio in the questions. That gave them about 38,000 examples.
And for testing, they used.
MMAU Test Mini.
Yeah.
That's a tougher benchmark designed to really test advanced LALMs, sound events, music, speech, the whole works.
Right. It's important to remember they use different data for training and testing, right? Out of distribution testing, I think they called it.
Yeah, that's crucial. Testing on data the models hadn't seen before, that tells you how well they can generalize. It's a better measure of true understanding, not just memorization.
So for those supervised fine-tuning experiments, what kind of prompts did they use again, just to recap?
They kept it super simple. Just prompt one, which was just, what's the answer? No show your work, no formatting instructions.
And how did the different training methods compare in terms of like stability, how smoothly the learning went?
The convergence graphs showed some interesting things. Supervised fine-tuning, especially when they tried to fine-tune all the parameters, that struggled with this smaller data set. They saw overfitting, where the model does great on training data but actually gets worse on new data.
Okay, not good.
RL, on the other hand, much smoother sailing. Clear improvement over time. And that Loral approach, which is a more efficient way to fine-tune, that was more stable than full fine-tuning, but still didn't match RL's performance.
So for all the learners out there, why should they care about this research? What's the big takeaway?
This research is exciting because it suggests a more efficient path to building powerful AI that understands sound. Think about it. If we can get great results with less data, that opens up a lot of possibilities. Smarter virtual assistants that really get the nuances of your environment, better tools for the visually impaired to navigate the world through sound, even more advanced audio analysis for things like security or environmental monitoring.
Yeah, those are some real game changers.
And then there's the deep thinking mystery, right?
Yeah.
That tells us we still have so much to learn about how these models, especially with audio, are actually working. We can't just assume our usual methods will translate.
Right, it's a whole new way of thinking about AI.
Exactly. And the comparison between RL and SFT, that's valuable too. It shows us that we need to be open to different training approaches depending on the task. RL might be the winner in certain situations, especially when data is limited.
And that point about AI still being behind humans in audio understanding, that's a good reality check, right?
It is. We're making progress, but there's still so much room for improvement. Research like this, exploring new training methods, that's going to be key.
All right, let's wrap up. Key takeaways from our deep dive into reinforcement learning for audio question answering.
Big picture, RL, specifically that GRPO algorithm, can really boost AQA performance, even with limited data. Beat out SFT, which is impressive. But that whole deep thinking thing, that's a puzzle. Shows we've got a lot to learn about how these models understand sound. And yeah, AI still has a way to go to catch up to human abilities, which means more research is crucial.
Absolutely fascinating. Now, for you listening, here's something to chew on. If explicitly telling the AI how to think didn't work, what other ways could we help it truly grasp the richness of audio? Could we learn something from how humans do it? Lots to think about. Thanks for joining us for this deep dive.